Hi, this is Stephen, and in this video we will discuss how to quantify right ventricular size and function. Let's start with our apical four-chamber view. So we have the left atrium that empties into the left ventricle. Add a little thickness to that wall, and then over here we have the right ventricle. And we want to measure the dimensions of the right ventricle when it is full of blood. So that would be at the end of diastole, so QRST, that's systole, and then you got your P, and then right before the next QRS, that would be end diastole. And what can we measure? Well, we can measure the diameter at the base. That should be about 4 centimeters. Anything above 4.1 centimeters would be abnormal. And then we can measure right here at the mid. That should be about 3 centimeters. Anything above 3.5 centimeters would be considered abnormal. And then we can measure the length. And so the length all the way from the top to the bottom, that should be about 7 centimeters. Anything above 8.3 centimeters would be considered abnormal. How about RV function? Well, for RV function, we'll get that again from the apical four-chamber view. So left atrium, emptying into left ventricle with our right ventricle over here and right atrium. And what we do, there's two different ways that we typically use. Remember, we don't have the orthogonal view of the right ventricle, and also the right ventricle shape, it wraps around the left ventricle, so it's much less easy to get an ejection fraction from volumes. But what we can do with 2D echo is we can use M mode. M stands for motion, and what we're looking at here is we're looking at the displacement over time. So that's the displacement in centimeters over time in seconds, and of this spot right here. I'm just gonna make this a little darker. Right here, the lateral aspect, right where the tricuspid valve inserts. And what you'll see is something like this. And we measure this distance. We call it the tricuspid annular plane systolic excursion, and that should be greater than 1.7 centimeters. That would be normal. And again, that's how much this spot right out here, that tricuspid annulus on the lateral side, how much that is moving up and down along that M mode line. So that's one way to quantify RV function. Another way is to use tissue Doppler. So let's look with tissue Doppler. And again, we're measuring that lateral insertion of the tricuspid valve. And with tissue Doppler, you'll get a graph like this. Tissue Doppler is similar to Doppler measuring the flow of blood, but it measures lower velocity, so centimeters per second by seconds. And you'll see S wave, and then you'll see some waves like this. We'll get into that in more detail in subsequent videos. And this S prime, which is the velocity of that tissue, should be greater than or equal to 10 centimeters per second. That would be a normal functioning right ventricle. So basically, we're looking at this point right here in both cases, that lateral wall, and we're looking either at the quantity that it moves up and down, it should be at least 1.7 centimeters, or we're looking at the velocity at which it's moving up and down, which should be greater than 10 centimeters per second. Either of those would be considered normal right ventricular function. Now, you can also do the fractional area change, and that is where you simply draw out the biggest area from the apical four-chamber view. You subtract the smallest area of the right ventricle, and you divide it by the larger area. That is the fractional area of change, and a normal fractional area change, FAC, would be greater than 35%, greater than 35%. Let's move this a little bit. We're going to write this. I'm going to write this down here. Fractional area change should be greater than 35%. Now you can do an ejection fraction with 3D volumes if you have access to 3D echocardiography. So the right ventricular ejection fraction by 3D should be greater than 40%. Greater than 45%. But typically, the two that we most commonly use would be the TAPSE, would be the S prime, to quantify our right ventricular function.